Alright guys, so the last topic for our Unit 3 for functions is we're going to learn how to write a function rule. So essentially what we're going to do is we're going to make our own function. Okay? So the general outline for these is you're going to have... Can I write it there? Okay? So generally you're going to write it, they're all going to be straight lines, so we're going to have f of x equals ax plus b. We'll have to find a first, and then we'll manipulate it somehow to get the b. Okay? So just keep that in mind. We're doing f of x equals ax plus b. So here's the first thing we're going to do. I'm going to give you some tables, and you have to make the rule that follows what's given. All right? So what I do is I'm going to read down each list and see if I notice any kind of pattern going on. Okay? So my x values are 1, 2, 3, and 4. Now if you sit and stare at that long enough, you might notice that it takes one number to get from 1 to 2. That's one jump. And then 2 to 3 is 1. 3 to 4 is 1. Okay? Then on our f of x values, we have 5, 6, 7, 8. So again, 5 to 6, that's 1. 6 to 7 is 1. 7 to 8 is 1. And if you'll notice, it may not necessarily be 1 all the time, especially over here on the f of x part, but it should be consistent or constant. It should stay the same. That lets you know that we're going to have that ax plus b pattern. So let me write that here so I don't forget it. All right, so we're first going to find the a value. And the way I'm going to write something really fancy here, I'm going to call it the... Now, it looks like two little triangles, but those are the delta. So this is delta. It's a Greek letter, and it stands for change. Okay, so we read this as the change in y over the change in x. Okay, and by change I mean what's your constant pattern. All right. So the y's are always on top. So what was our change all the time? It was 1. Our changes in x were always 1. So then this equals 1. So we've got a equals 1 for this problem. All right, so we have built 1x plus b. Okay? So in other words, it starts with 1 times the x value, and then we have to add something to it. Okay? So let's see if we can find out what b is now that we figured out what a is. If you stick this 1 down here in x, 1 times 1 is 1, right? That's not what I was given. I was given 5. Well, if I'm going from 1 to 5, how many more do I need to add? I'd have to add 4, right? Let's see if that works for 2. If I put 2 in here, 2 times 1 is 1, but I really need 6, so I have to add 4 more to get to 6. The same is true for 3 and 4. So we just found our b value to be 4. So our function is x plus 4. Okay? And if you're still a little confused about it, don't worry. I've got 3 more to go through for the table. Okay? So let me erase what I've got. Okay, let's come over here to the second one. We got x and y. So remember, we're using ax plus b, and a is going to be change in y over change in x. All right? So let's look for our changes. So 1 to 2, that's 1. 2 to 3 is 1. 3 to 4 is 1. Okay? This might stay 1 the whole time. It doesn't have to be, but I think for what I've done, it is going to. But I might be wrong. We'll see. All right, let's check our y's. 2 to 4, well, you add 2 each time. 4 to 6, we're going to add 2. 6 to 8, we're going to add 2. So this time, excuse me, it's not 1, it's 2, but it's okay as long as it's the same number each time. All right. So now let's figure out our a. The change in y is 2. Change in x was 1. So we say 2. A is 2. So I'm going to use y this time because they gave me y. And so y equals 2x plus b. Let's see if we need to add anything here for b now. Okay. So I'm gonna take 1 and stick it right here in 2 times x. So 2 times 1 is 2. And that's what I had. Let's make sure. Let's try it 2. 2, put the x in here. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. So it looks like I'm not adding anything here on the end, so we can just say our function is 2x. All right. Let's scroll down here and look at my other ones. All right, try to leave me a little bit of room. Okay. So sometimes functions are going to be in a more realistic context. So this time we're talking about cans of soup and number of servings. This would be like our x's, and this would be our f of x's. Remember we talked about f of x being dependent and x being independent? Number of servings depends on how many cans of soup you have, so that's why we call this right side f of x. Okay? So let's leave that, well, I'm going to erase it. So just know that this is our x, and this is f of x. Now, just don't get totally used to seeing f of x. You could see like c of t, g of n, or the letters might change, but it's the same idea. This notation means f of x or the y values. All right. Ax plus b. A is changing y over changing x, so let's see. -2 to -1. Well, I add 1. -1 to 0, I add 1. 0 to 1, add 1. All right, let's check our y's. -8 to -4, that looks like I have to add 4 to get there. And then I'm going to add another 4, and then add 4. So I've got the change in y is 4, the change in x is 1, so a is 4. So I have f of x is 4x plus b. Let's see if I need to add anything for b. So start with your x and plug it in here. -2 in here for x. What is -2 times 4? That's -8. Okay, put -1 in here. Take -1, put it here for x. -1 times 4 is -4. And then 0. 0 times 4 is 0. 1 times 4 is 4. So I'm not having to add anything extra to get these numbers in the table. So I don't have a b. And so I say that f of x is just for x. All right? All right, last one. So now we're talking about number of cans of frozen orange juice versus the cost. Well, obviously the cost is going to be f of x. So however much you spend depends on what you're buying. Okay? So let's check our pattern. 1, add 1, add 1. Okay? So now, how far is it from half to 1? Well, that's another half. And then add another half, and add another half. All right, so I have the change in y over change in x. That is 0.5 over 1, which is still 0.5. So my a was 0.5x. Let's see if I need to add anything here for b. So take your first x and plug it in here. 1 times half is a half. Okay, let's plug 2 in here. 2 times a half is 1. 3 times a half is 1.5, or 3 halves. 4 times a half is 2. So, just like the last one, we're not adding anything. So f of x is going to be 0.5x. All right? That's the general idea when you have a table. You want to find this pattern in your x's and then your y's, and then write it as the changes in y on top, the changes in x on the bottom, and whatever you end with here, whatever you end with here is the a value. And then you have to double check if you need to add or subtract anything to the b value to get your actual function values. And there's a few of these on your homework, so you'll be able to practice it then. Okay, now we're getting into word problems, which are not super hard. All you have to do is either write the function or you might have to plug a number in every now and then. Okay? So let's just see what we have to do. So this first one says the total cost, T of C, if C ounces of cinnamon, if each ounce costs 79 cents. This word should be of. Sorry, I don't know why it says if, it should be of. Anyway. Okay, so our function is T of C equals some kind of expression with our variable C here. And they tell us that each ounce is 79 cents. So obviously you buy 1 ounce at 79 cents. Here's what we could do. We could build us a table. I shouldn't use XY, I should use what I was given. C ounces, T of C. So 1 ounce is going to cost me 79 cents. What's 2 ounces going to cost me? Well, let's figure it out with the calculator, because I really don't know. That's going to be $1.58. What's 3 ounces? Gives me $2.37. And then you could do what we just did with tables. There's a difference of 1 here, difference of 1. This is 0.79. This is 0.79. So then you would have 0.79 over 1, then you'll get 0.79c as the function. Okay, that's not necessarily how I would do it. I just kind of like do some common sense in my head. Like I would do this table sort of in my head. So I know if I did 1 ounce of cinnamon, it would cost me 79 cents. If I buy 2 ounces, it's going to cost me $1.58 because I'm adding another ounce. Okay, and if I do 3 ounces, that's $2.37. I know in my head that I'm really just multiplying the 79 cents per each ounce. Does that make sense? And so it's 0.79 times C, or we just write it like this. Okay. Let me show you what I mean with some other examples of just doing it like kind of common sense in your head. If you're more comfortable with the tables, then by all means do the table. I just think it's a little much for me to do when I don't have it, so I just don't do it. All right, so the total distance, d of n, so I'm going to write that down, traveled after n hours at a constant speed of 45 miles per hour. So n is our variable, so I have to write that down. Now I need to put something in front of it. So it says a constant speed of 45 miles an hour. So I start from some location and I travel at 45 miles per hour constantly. I don't change. So after 1 hour, that means I've gone 45 miles. After 2 hours, I've gone 90 miles because I would add another 45. After 3 hours, I would have gone 135 miles. And then 4 hours would be 180 miles. So it's like 45, 90, 135, 180. You're adding 45 each time. Or for each hour, you're multiplying it by 45. So this one is just going to be 45n would be your function. Because n is the hours you're plugging in. So if you've gone 4 hours, be 4 times 45, which is the 180. All right? So if they asked you, how far have you traveled after 6 hours, you would say d of 6, 45 times 6, which is, Lord, I don't know what that is, but yes, I do. Hang on. 270. Be 270 miles that you've traveled. That's really the idea. I just kind of think about it in my head because most of the time this is going to be some multiplication. Like I'm pretty sure it's like 99% of the time when you write this function, it's going to involve multiplication. Okay. Sometimes you might have to add or subtract something, but we'll see. Am I as far down as I can go? Yep. Okay. So last one, a worker's earnings E of n for n hours. So I'm going to put my blank for my number in front and then n. When the worker's hourly wage is $6.37. So it's just like this traveling question. You work 1 hour, you get $6.37. When you work 2 hours, you're going to get $12 and some odd cents. You just multiply this number for every hour you work. So $6.37 times n is going to be your function. All right? Let's go on to the next one. So at a supermarket salad bar, like at Big Fancy Kroger, the price of a salad depends on the weight. So price depends. Okay? Salad costs 19. Okay, so make sure to read this carefully. It's $0.19 per ounce. So 0.19 per ounce. All right? I'm glad it's 19 cents and not $19 because that would be really expensive. But anyway. So we're going to make our function, and because I wasn't given anything specific, I can choose what letters I'm going to talk about, what I use. So since we're talking about price, I would use like P. Let me show you what I mean. So we're going to write a rule to describe the function. So I could say P of n. So the number of ounces is independent. That's what I'm going to put in my salad bowl. And then the price, P, depends on that number of ounces. So again, if I buy 1 ounce of salad, it's 19 cents. If I buy two ounces of salad, it's going to be 38 cents. I'm multiplying that each time, so it's 0.19 n would be my function. Okay. Then how much would an 8-ounce salad cost? So now I'm going to take this 8, that would be my number of ounces, 8, and use my function. So P of 8 is 0.19 times 8 And I really don't know what that is, so let me find that out super quick. 0.19 times 8 is $1.52. And since we're talking about money, don't forget your dollar sign. There you go, $1.52. That's a cheap salad, by the way. All right, last one. Suppose you borrow money from a relative to buy a lawnmower that costs $245, so keep that in mind. You charge $18 to mow a lawn. Write a rule to describe your profit. So let's talk about profit for a second. Now, you all learn economics, and I don't know if you've learned it yet, but you should know that profit is going to equal your revenue minus the cost. So revenue is like all the money that's involved in the project, how much you've spent and how much you're charging, and then you have to subtract off the initial cost before this, okay? So let's figure out our revenue. Revenue comes from this line right here, $18 to mow a lawn. So for every yard you mow, you're going to get $18. So you mow 1 yard, it's 18. 2 yards is 36. 3 yards is 54. You're multiplying each yard you mow by 18. Okay? So I'm going to say P of N. My board just had a stroke. I don't know why. Let's scoot down a little bit. So it's going to be 18 times the number of yards I mow. Now I got to worry about the cost. Because a profit is really the money you earn. The money you spent on the cost for the lawnmower doesn't really earn you anything, so you got to subtract it off this revenue we're talking about here. Well, how much cost did I spend? Well, I spent $245 for a lawnmower, so I have to come down here and subtract $245 from it. Okay? And then a further question on this that could ask you, what profit do you earn after mowing 30 yards? Or something like that. So we would have to do P of 30 equals 18 times the number of yards I mow, which is 30, subtract my cost of $245. So let's do that. 18 times 30 is 540, subtract 245. So I get 295. Okay? Let me demonstrate again with something with a different kind of problem. Let's say, what is it after 5 yards? So let's do P of 5. That's 18 times 5 minus 245. I think 5 times 18 is 90, but let me double check. Yeah. 90 minus 245. It's negative 155. Okay, that's dollars. Okay, so I did this reason because mowing's 5 yards doesn't make you a profit because this is negative. You're not going to earn a profit until this final value here is positive. Okay, and if it's 0, that's your breaking point. Okay? Alright, so that's all about writing a function rule. You do have a homework assignment to go with this, and I'm going to post on Google Classroom the specific problems you have to do. So look on that for how many you have to do. Hope this video helps with writing a function rule. And again, this is the last new topic in Unit 3. We're going to do a study guide on Tuesday, and we're going to take a test on Wednesday. So wrapping this up.